Hey, this is Mr. Hanson. I wanted to talk with you today about multiplying polynomials. This is an extension from the adding and subtracting polynomials. Let's take a look at some of these rectangular diagrams we've got here. So with the first one, this length is x, and this length is 4 units right there. And this length is also x, and this length is 2 units there. So I want you to think of maybe two different ways to figure out the area for that rectangle there. So if you were thinking about length times width, it would be x plus 4 multiplied by x plus 2. And that's one way to do it. You may have broken it down into pieces. So you could say x times x, that's x squared here. And here we'd have this x kind of comes over here too. So 4 times x, that's 4x. So 4x. And then down here we've got, this is a little x there. So 2 times x, that's 2x there. You kind of see that. And then we've got 4 times 2, this last little rectangle, 4 times 2, which equals 8 there. So let's just clean this up a little bit. You could also say x squared plus 6x, 4x plus 2x, and 6x plus 8. So the idea is you can write a problem as length times width, the product of two binomials, or you can write it as one trinomial, x squared plus 6x plus 8. These two expressions are equivalent to each other. And that's much of the focus of what we're going to be doing today and next time, where if you've got the two binomials, you can multiply them together to get a trinomial. And if you've got a trinomial, you can factor it to move it back to two binomials. I like the picture diagram. I think it kind of helps put things into perspective. Let's look at this next one. We've got x here and x there and x there. And we've got 2, let's just call that 2 there and 2 there. So it looks like we have x plus 2, that's 2x plus 2 for the length times x plus 2 for the width. Okay, so now if you think about kind of breaking these down a little bit, you kind of see, I'm going to make them kind of longer, or I think I went the wrong way on those. Let's try cleaning it up just a little bit. Something like this maybe. Okay, so here's an x squared. Here's an x squared. You kind of go length times width, figure that out, and length times width again. And then length here times width, so x times 2, that's going to be 2x there. And here we've got length times width. That's going to be x and x squared. So let's just do it a piece at a time. We've got 2x here and another 2x there. And then we've got 2 times 2 is 4. So we end up with 2x squared plus 4x. Nope, not 4x. We got 2, 4, 6x. Plus 4, right there. 2x squared plus 6x plus 4. And that's the trinomial that it makes when you multiply those two together. Okay, so that's kind of how it works. Let's just take a look at a couple of different thoughts here with this multiplying two binomials together. My first thought is that if you took x, right here, the underlined x, and distributed it out to this part here, and then you took -4 and distributed it out to that part there, it looks something like this. X times x plus 2 minus 4 times x plus 2. So when we go ahead and multiply, we get x times x, that's x squared, plus 2x, minus 4x, minus 8, which is x squared. These can be combined, minus 2x, minus 8. So these are the same exact thing. This two binomials multiplied together equals this trinomial there. And if you put in a number, let's just put in a number that's maybe easy to work with, like 3, and just see what happens. So if I put in 3 there and 3 there, 3 plus 2, that's 5, and 3 minus 4, that's negative 1. 5 times negative 1 is negative 5. I'll just kind of keep that there. Now we're putting in 3 here, that's 9. And negative 2 times 3, that's negative 6, so we're down to 3, and 3 minus 8 is also negative 5. So just kind of showing you those expressions give you the same exact thing every time. Okay, so it's really the distributive property is all it is. You just have to think about distributing a piece of something to another bigger thing. So let's look at this one. We've got a binomial multiplied by a trinomial. And let's see what we can do here. We're going to take this piece, this x squared, and distribute it to 3x cubed, and then 2x squared, and then x. So we'll take that piece. So 3 times, or x squared times 3x cubed is going to be 3x to the 5th. X squared times negative 2x squared is going to be negative 2x to the 4th. X squared times 2x is going to be x cubed. I'm sorry, x squared times x is x cubed. So there we go. And now let's just do this one in a different color so you can kind of see. We got to distribute that 2 to each of these right here. And so 2 times 3, that's 6x cubed. And I'm going to put it right here because in a minute I'm going to have to add these two things together. And 2 times negative 2x squared is negative 4x squared. And 2 times x is 2x. Okay, now we can kind of add everything together. So we'd have 3x to the 5th minus 2x to the 4th plus 7x cubed minus 4x squared plus 2x, like that. So just remember, I think maybe the easy way when you multiply stuff that has a lot of terms in it, just take the smaller one on the left, multiply it by the first part by each of the parts on the right, and then multiply the next part by each of the parts on the right, and then add them all up. That's kind of what we're doing there. Okay, there's one shortcut when you're multiplying two binomials together, and it's called FOIL. So FOIL, F-O-I-L, first. So we're going to multiply the first term by the first term, 2x times x, outer. So outer, we're going to go negative 6 times x, inner, and we're going to go plus 3 times 2x, and last. FOIL, first outer, inner, last. 3 times negative 6. And we get 2x squared minus 6x plus 6x minus 18. And this one happened to work out kind of interesting. We actually, these cancel out, these terms here, and you get 2x squared minus 18, like that. So there you have it. FOIL is a good way to do when you're multiplying two binomials together. Okay, one last thing. I wanted to do some kind of word problem here. So if you owned a movie theater and there are 200 seats in the movie theater, and your ticket price is $10, and you can do price increases. So X is the amount of price that you're increasing by, okay? So ticket price equals 10 plus the price increase. And then tickets sold, you've got 200 seats, but each time you increase the price, by $1, you lose 10 seats. Okay, so that's sort of what's going on. And you want the ticket sales. So we've got 10 plus x times 200 minus 10x. Let's do that FOIL. So I know that it's not written notationally correct. Usually you have the x's out front, but let's just go ahead and do this. So first times first, 200 times 10, 200 times 10, plus 10 times negative 10x. So that's the outer. And then the inner plus 200 times x. And then the last minus 10x squared. So let's clean this up a little bit. We've got 2,000 minus 100x plus 200x minus 10x squared. And I'm going to be a little bit compulsive about this. I'm going to do it in the right order. So negative 10x squared plus 100x plus 2,000. Okay, so these are ticket sales. We can kind of create a function out of this. I'm just going to put f of x right here. And now what we can do is we can plug in the number 1. So we'd have negative 10 here, plus 100, that's 90. So negative 10 plus 90, that's 80. That'd be 2,080. I messed up here just a little bit. Okay, let's plug in 2. That's going to be negative 40 plus 200 plus 2,000, so it's going to be 2,160. Plug in 3, you get 2,210. Plug in 4, you get 2,240. Plug in 5, you get 2,250. Plug in 6, you're back down to 2,240. So this kind of gives the movie owner an idea of how much they want to increase their price by. If they increase by $5, it's $15 a ticket, but they'll make the most money right here when they've increased by $5. If they increase by $6, they're losing too many seats to make it work. Or if they increase by $4, they're not quite making enough money to count for the lost seats. So that's just kind of one example of a multiplication problem with polynomials. So in this lesson, we did a word problem with polynomials. We talked about the FOIL method when multiplying two binomials together. We talked about the fact that multiplying polynomials together is just a distributive property. And we looked at a few area problems to help you understand the product of two binomials is usually just a trinomial. Hope this helped. Thanks and have a good day.